Hey everybody, in this video we're going to talk about performing elementary row operations. Let's back up a little bit and connect this to solving systems of equations. So when we solve a system of two equations, two unknowns, let's say we have these two equations, negative 3x minus 5y equals negative 13 and x plus 2y equals 5. Now, it doesn't matter which order I look at these at, right? I could interchange the equations and look at the system like this. So the x plus 2y equals 5 equation 1, let's say. Now, if I multiply let's see, got my pen now, by 3 on the top. So I multiply this equation by 3. I'll get 3x plus 2y, plus 6y equals 15. And negative 3x minus 5y equals negative 13. So now, what I did when I solved these is I worked with these equations in order to eliminate this variable x, and then I would get y equals 2 after I add the equations. So these are the elementary row operations that we can do to systems of equations in order to eliminate variables and solve for the variables that we need. You can do the same thing, but with matrix form. Because remember, what does this system of equation look like in matrix form? This looks like negative 3, negative 5, negative 13, and 1, 2, and 5. So remember that, and we're going to go over these elementary row operations with matrices. So the elementary row operations that we're going to use with matrices are the same. We can interchange rows, so row 1 and row 2 can swap, just like when we swapped the equations on the previous portion. So then we would get the matrix 1, 2, 5, negative 3, negative 5, and negative 13. So we just interchange those two rows. The next thing we can do is we can multiply a row by a non-zero constant. So we can take 3 times row 1 and replace that with row 1. So now we're working with this system, or this matrix, 3, 6, 15, and negative 3, negative 5, and negative 13. So I just multiplied 3 by this first row. Then the next thing I can do is I can add a non-zero multiple of one row. So I can take a multiple of one row and add that to another row. So if I take 3 times row 1, that'll be 3 times row 1, and then I add row 2, and then replace that with row 2. So it's almost like taking it's exactly like taking 3x plus 6y equals 15 and adding negative 3x minus 5y equals negative 13. And what did we get when we got that? We got y equals 2. And this becomes my new equation, or my row 2. So my row 1 stays the same because I'm only swapping this with row 2. So row 1 is the 1, 2, and 5. And then row 3 is going to be the y equals 2, or 0x, 1y, and 2. So these are the 3 elementary row operations that we're going to use. let's go ahead and do some practice. So what will interchanging row 2 and row 3 look like? We are just going to take row 2 and row 3 and swap them. So we will get row 1's not going to change at all. 4, 3, 0, 5. And then row 3 was 2, 0, negative 3, and negative 8. And row 2 was 1, 4, negative 1, 9. And you can see if I swap row 2 and row 3 back, I'll end up getting the same matrix I had before. Okay, the next one, 1/2 times, or negative 1/2 times row 3. So I'm literally only going to take this row 3 and multiply it by negative 1/2, and then I'm going to replace that with row 3. So in this case, this is a separate problem. Did row 1's or 2 change from the original? Oh, row 1 is 4, 3, 0, 5. And row 2 is still 1, 4, negative 1, 9. And then 1/2 times, or negative 1/2 times row 3, we take negative 1/2 times each of our entries in row 3. So negative 1/2 times 2 is negative 1. Negative 1/2 times 0 is still 0. Negative 1/2 times a negative 3 is a positive 3/2. Then negative 1/2 times a negative 8 is a positive 4. So this becomes my new matrix that I'm working with. Or, in other words, think of it as 3 new equations that we're working with. Or 2 of the same equations and 1 new equation. 4, negative 4 times row 2 plus row 1, and then replacing that with row 1. We're going to multiply row 2 by negative 4. And that's going to give me negative 4, 4, negative 1, and 9. Then I'm going to add row 1, which is 4, 3, 0, 5. When I add these together, these numbers are what I'm going to replace row 1 with. Negative 4 plus 4 is 0. 4 plus 3 is 7. Negative 1 plus 0 is negative 1. And 9 plus 5. I made a mistake. I didn't multiply this times 4. I didn't multiply any of these times 4. So I needed to multiply negative 4 times every entry in row 2. I only did it with the first one. So let's try this again. Negative 4 times 1 is negative 4. Negative 4 times 4 is 16. Negative 4 times negative 1 is a positive 4. And then negative 4 times a positive 9 is a negative 36. So now let's try this. Negative 4 plus 4 is 0. 16 plus 3. Negative 16 plus 3 is negative 13. 4 plus 0 is 4. And negative 36 plus 5 is negative 31. So my new matrix, since I wanted to replace row 1 with this bit, is 0, negative 13, 4, negative 31. In row 2 and 3, I haven't changed at all from the original. So that's 1, 4, negative 1, 9. And 2, 0, negative 3, and negative 8. So there's a little bit of an introduction to performing row operations on a given matrix.